In this video, we will graph linear equations by finding intercepts. If you watched the video on plotting points, you might remember that a graph is not made up of just random points. Those points become the solutions to the given equation. Then, as we are being asked right here in example 1, to graph the following equation into variables, what we're going to do is we're going to begin by selecting values for x, replacing them in the equation, and find the value of y that will make the order pair a solution to this equation, 3x plus 2y equals 6. We then plot the order pairs in the coordinate plane and then graph the line by connecting the points. So, since we're not given any values, I'm going to begin by selecting a number myself for x. Let's try a 1. So then I go to the equation, and then right here where I see an x, I'm going to replace it with a 1. Bring down the rest, and I simplify. Well, 3 times 1 will be 3, plus 2y is equal to 6. We solve by subtracting 3 from both sides, and I get 2y is equal to, well, on the right side that will be 3. The reason for this is because 3 minus 3 will go to 0, and 6 minus 3 is 3. Lastly, we divide both sides by 2, and then we end up with y is equal to, let me write it on the side, y is equal to 3/2. And if you put this in the calculator, it's going to give you 1.5. Okay, so this is a y value. Now, because we get a fraction, it might be a little difficult for us to graph the fraction or the decimal form in the graph. We will have to approximate where it's located. So I'm not going to plot this point because it's a fraction. I'm going to try a different number. Let's see what happens if I try an x value that is the same as a coefficient of y. Now here is y. In the equation, I'm going to try this number, the one that is the coefficient of y. So that means that I'm going to bring down my equation, 3x plus 2y is equal to 6, and I'm going to replace this x with a 2, because that's the coefficient of y. I bring down the rest, and I simplify. 3 times 2 will be 6, plus 2y is equal to 6. So we need to move this 6 first when we're solving for our equation. So 6 minus 6 will turn into a 0, leaving us only with 2y. And on the right side, 6 minus 6 again will also be a 0. So then we have a 0 on the right side. We're not done, remember. We still need to divide by 2 so that we can leave y by itself. So 2 divided by 2 is 1y, or just y. And on the right side, 0 divided by 2 will be 0. So then the next point is 2, 0. This gives us a whole number order pair. So let's plot it. This is 2, 0. That means that my point is on the x-axis. This is a point, 2, 0. Now, because 2 worked, I'm going to try the same number again, but instead of being positive 2, I'm going to use negative 2. Now, what I mean by 2 worked, it means that it gave us a whole number answer. It doesn't mean that 1 didn't work. 1 worked. It's just that it gave us a fraction, and we don't want to approximate or guess where that fraction is located. So let's try now negative 2 and see if negative 2 gives us a whole number result. I bring down my equation. I'm going to replace my x with negative 2. Bring down the rest. I simplify. 3 times negative 2 is negative 6. Bring down the rest. And then we solve for y. We move anything that is being added or subtracted. So since this is -6, I'm going to start by adding 6 on both sides. -6 plus 6 will go to 0, leaving me with 2y. And on the right side, 6 plus 6 will give me a 12. Remember, we're not done. We still need to divide by that 2 in front of y. So we divide by 2 both sides, and that gives us that y. Let me put the result over here. 2 divided by 2 is 1y, or just y. And on the right side, 12 divided by 2 will be 6. So then the y result is another whole number. That means that I will be plotting this point. So -2, 6. So that means that we're going to go 2 to the left and 6 up from the origin. So that is 1, 2 left, and 1, 2, 3, 4, 5, and 6. So here's where I plot my point, -2 and 6. All we have left to graph the equation is to connect the points. And we have graphed the equation 3x plus 2y equals 6 by plotting points. Now, graphing by finding the intercept is the same process as the previous example, but this time we don't just select numbers at random or numbers that match the coefficient of either variable. What we do is we must select two specific values that give us the x and y intercept. Now, this is where the graph is going to cross the x and y axis. So let's begin. It says here, to find the x-intercept, what we're going to do is we're going to let y equal to 0, and then we're going to solve for x. So let's do that. I'm going to bring down the equation. It's going to be the same equation as in example 1, just so that we can see if this method matches the same graph as example 1. So I'm going to bring down 3x plus 2y is equal to 6. And what we're going to do to find the x-intercept is we're going to let y equal to 0. Remember, what we're looking for here is the x-intercept. So that means everywhere I see a y, I'm going to replace it with a 0. Let's bring down the rest. So this becomes the 3x plus a 2 is equal to 6. Now we multiply 2 times 0. 2 times 0 will go to 0, leaving only 3x is equal to 6. Now we're not done. We need to solve for x completely, so then we're going to have to divide by that 3 that is in front of the x. So 3 divided by 3 will be 1x, or just x. This goes to 1. That's x is equal to 6 divided by 3 will be 2. So then the x-intercept is located at 2, 0. Let's plot that. 2, 0 is where our graph is going to cross the x-axis. Let's try it again now. But now we're going to look for the y-intercept. And it says here that the y-intercept is found by letting x equal to 0 this time. So then we're going to still use 0, but this time we're going to use the 0 on the x. Remember, this is going to give us the y-intercept where the graph crosses the y-axis. So we bring down the equation again. 3x plus 2y is equal to 6, but this time we're going to replace the x value with a 0. Bring down the rest. So this is 3 plus 2y equals 6. We multiply first. 3 times 0 will go to 0, so that's going to disappear, leaving us with 2y is equal to 6. Now we're not done yet. We need to divide by that number in front of the variable. So we need to divide by 2 both sides of the equation, and then we say, well, 2 divided by 2 is 1, 1y, or just y. And on the right side, 6 divided by 2 is 3. So then the y-intercept becomes 0, 3. Let's graph that. That's going to be on the y-axis at positive 3. So here is, let me label them. This was 2, 0. This was the x-intercept. And up here I get 0, 3. And this is the y-intercept. Let's graph the equation by connecting the 2 points. Notice how we get the same graph as before, and you might be asking, how do I know this is the same graph? Well, we can go back to the equation and see what points were plotted on the first example. Now this point matches the one that we just graphed. So 2, 0 matches. Let's see if negative 2, 6 is also on the graph that we just plotted using the x and y intercept. So 2, 0 is there. Let's do the other one. The other one was negative 2, 6. So that means 2 to the left, and then 1, 2, 3, 4, 5, and 6. And 2, 6 also lands on the graph. So that means that the two graphs are the same. Now, there will be times when using this method that it gets a bit tricky. Like what happens if both the x and y intercepts are equal to each other? If we end up with the same point twice. Remember, to graph a linear equation, we need at least two distinct points. Otherwise, we won't know in which direction to graph our equation. So then let's graph another example to see what happens when we use this method and we end up that the x and the y intercept are the same. Let's say that your equation is 3x plus 2y is equal to 0, and you still want to use the x and y intercepts to plot this graph. So let's start by finding the x-intercept. Remember, we do that by letting y equal to 0. So I'm going to let y equal to 0 so that I can find the x-intercept. I bring out my equation, 3x plus 2y is equal to 0. And I'm going to replace this y with a 0. Bring down the rest. I have 3x plus the 2 equal to 0. Well, 2 times 0 will be 0, leaving you only with 3x is equal to 0. We're not done yet. Remember, we need to divide by the coefficient of x. We need to divide both sides by 3. So 3 divided by 3 will give me 1x, or just x. And on the right side, 0 divided by 3 will be 0. That means that the x-intercept is located at 0, 0. Let's plot that. Then we do it again. We're going to now, we did this one, we're going to now find the y-intercept by letting x equal to 0. So let's find the y-intercept. Okay, so I bring down my equation, 3x plus 2y is equal to 0. I'm going to replace this time the x value with a 0. Bring down the rest. And 3 times 0 will be 0, leaving me only with 2y equal to 0. We're not done. We need to divide by the coefficient. We divide both sides by that 2. Now 2 divided by 2 is 1y, or just y. And on the right side, 0 divided by 2 is going to equal to 0. So what happens is now, since both the x and y intercept are the same point, I don't know in what direction to graph my line. Where should I go to from 0? Should I go up and to the right, down to the right, up to the left, down to the left? I don't know what direction. So what we're going to have to do is, when this happens, we're going to have to select another value for x so that we can find a third point. And hopefully this third point will be different from the first two so that we can graph our equation. Now, just to follow the same trend as we did for example 1, I'm going to select the coefficient of y. I'm going to select 2. Now let me move these two so that I can give myself some space to work the next point. Now the third point we're going to try is we're going to let x equal to 2. The reason we selected 2 is because 2 is a coefficient of y. So then I'm bringing down my equation, 3x plus 2y is equal to 0. And I'm going to replace this x with a 2. Bring down the rest. When we multiply 3 times 2, that gives us 6. Bring down the rest. And this time we have that positive 6 to move first. The way we move a positive 6 is by subtracting 6 from both sides. So 6 minus 6 will go to 0, leaving me only with 2y. And on the right side, 0 minus 6 will be negative 6. Remember, we're not done. We need to divide by the coefficient of the variable. In this case is 2. We divide both sides by 2. Now 2 divided by 2 will be 1y, or just y. And on the right side, negative 6 divided by 2, well, 6 divided by 2 is 3, but because they have different signs, that will be minus 3. So then the next point that I get is 2 minus 3. When I plot that, I'm going to see that this is a different point from the 2 that we got before. So I go 2 to the right and then 3 down. And this is the point 2, negative 3. And this was 0, 0. So now that I have two very distinct points, now I can graph my equation. So then when you are graphing by finding x and y intercepts, and you find that both the x-intercept and y-intercept end up being the same point, what you're going to have to do is find a third point so that you can graph your line. Remember, in order for you to graph a linear equation, you need two distinct points. And if both the x and y intercept are the same, you won't be able to graph your linear equation. You're going to have to find a third point. This 2, we selected this value because 2 was a coefficient of y, just as we did in example 1.
Thank you so much for watching, and I'll see you in the next one.